Long time ago in Unit 1, we looked at odd and even functions. A function f of x is odd if
That has negative power. Well, if it could be, if you put a negative and it's still negative. Like
If
it's
it gives you
negative,
the original function, something
like x squared isn't negative because like if you put a negative.
If f of negative x is negative f of x.
Yeah.
Lewis is giving me hope. F of minus x would be equal to minus f of x. But if f of x is an even function,
Then f of negative x is still equal to f of x.
that is correct.
See, that's the one I was thinking. You get the original function.
Okay, now. In a way, Gio was right in the sense odd power, even power, but it has to be just a single term, right? You can't have multiple terms. And the concept of trigonometric functions, if it comes into play, you've got to know this to determine if things are odd or even. Jordan, you know or you think?
I think.
Sine is odd, cosine is even, that is correct. That is a parabola, yes? Yeah. And y equals x squared. I want to find the area between -2 and 2.
Really just take half the parabola and then multiply it.
Exactly. So because of symmetry, instead of integrating all the way from -2 to 2, one can simply find the area from 0 to 2, multiply it by 2. Correct. Provided the distance here is the same as the distance there, and the function is even. Good. So if f of x is even, good. So -a to a f of x dx would simply be 2 times integral 0 to a f of x dx. That's it. Let's say I want to find the area, net area that's being -2 all the way up to +2.
It would again be the area from -2 to 0 and then multiply that by 2. It would be the exact same area, so it'd be the exact same.
It's the exact same area, so how would that work? The same as that?
I mean, if.
How many of you think it'll be exactly the same?
No,
No.
Why no?
because it's not that
Because it's just, yeah, one is even and one is odd.
Yeah,
Okay, we could do
That's
that's even,
value.
this is odd, also,
it's different function. Does that matter?
of course, that's different.
Correct.
So it goes, one is negative, like it's below.
One is negative, the other is positive.
The thing is, the area can't be negative or positive, area is just
Hold
area.
on, I'm not done yet. So if f of x is odd, then integral negative a to a f of x dx would be 0. Reason being, the area on this side would get rid of the area on that side. Now, mathematically, this is what we call the net area. But you do have to understand that if you're extending this to a practical application, perhaps, let's say you have a piece of carpet and you kind of cut it in this manner and you want to find the area via integration, for whatever purpose that might be. When you do that, would that area be 0?
No.
On a piece of carpet, area is area, right? It's not negative. So in that case, you will be adding this to that, right? A practical application. But from a mathematical standpoint, the net area is 0 because the area here will get rid of the area there. See the difference? So at the end of the day, you've got to use common sense, maybe engineering, maybe physics. If you're looking at it in a practical perspective, of course, area cannot be negative. So I can't simply get rid of the 2. What we're trying to say here is that the absolute, the net area is 0 because the area here will get rid of the area there.
And for functions that are not even like that, not even, but like not symmetrical, you would use the other thing, what we just learned before.
What do you mean other thing?
What we just learned like a class ago. We used to find the area of like both of like waves.
That has a name, one's that's like waving,
Non-symmetrical functions,
just like lace, what is it called?
like what?
Lace, waving.
Chip.
There you go. There you go. Couple of, we didn't call it the other thing. It had a name. Starts with a D.
Can I call for a friend for help?
Yes.
Do you know the name?
The definite integral, thankfully.
There you go.
I was thinking shit names instead.
I wasn't.
Even further about this, because in some functions, knowing this simple concept would make computations easier. Instead of integrating from here to there, I can just integrate that easily. Or simply say that is 0.